Welcome to our video on solving equations presented by 3MathGuys. Visit our website at 3mathguys.com and please subscribe to our YouTube channel. Okay, so we are going to look at solving equations. We're going to start with one that's relatively simple, but we're going to take a different approach than you might have seen before. We're going to look at three methods of solving this, numerical, algebraic, and graphical approach. And I'm going to start with algebraic, which is probably what most people are used to and have seen before. So just to give you an idea, x is some number that I need to figure out, and so when I get all done, at some point I want to know x equals and have some answer. And so to get from here down to here, well, I need to get x by itself, and so I need to cancel these terms off. You know, what's happening to x? Well, x is getting multiplied by 3, and then I'm subtracting 2, and so I'm just going to undo those kind of in reverse order. So the first thing I'm going to cancel off is this minus 2, so I'm going to add 2 to both sides. You can't just cancel 2 and say it's equal still. It's not equal unless I balance it by doing it to both sides. And so now the only thing left over here is going to be a 3x. This is going to equal 9 divided by 3 to cancel 3 times x, and I end up with these 3's simplifying down to a 1, canceling off, and 9 divided by 3 is 3. And so I've got my solution, right? And so this is the typical way that's taught in algebra classes, and it's a good way. It's probably the most efficient way. But we're going to look at a couple other ways you can do the same work, and how applying these other methods can help you have a deeper understanding of why is that the answer, and how do I know that's the answer. Okay, so let's look at what I'm going to call a numerical approach. And the way I'm going to do that is I'm going to write this side of the equation down. So I've got 3x minus 2, and we'll make this like an xy input-output table. And so I could plug lots of different numbers in for x, and if I plug a number in for x, I'll get one answer. If I change the number I plug in, I'll get a different answer. And what I want to end up finding is what value can I plug in so that when I finally get an answer, I get this 7 that I want. And so I'm just going to say this is some value y. We want to know when is it going to be a 7. So we can just start by plugging in numbers. I like to start by plugging in easy numbers. So probably the easiest one is plugging a 0. Well, if I plug in a 0 for x, 3 times 0 is 0, minus 2 gives me minus 2 for my y value. And then I'll just plug in another number. 1's usually pretty easy, so let's try that. 3 times 1 would be 3 minus 2 gives me 1. And then at this point, once I've got a couple data points, I'm going to ask myself, okay, what's the number I want? I want this y value to be a 7. So am I going the right direction here? I mean, this amount went up by 3. And do I want to keep going this way to eventually get to a 7? And I do. You know, going from -2 to 1. 1 is closer to 7 than the -2 was, so I must be going the right way. If you weren't, then you'd want to start plugging in values like -1, -2, so that you end up going closer to the number you're after. Right now I'm after a 7. Okay, and you can do this a couple ways. I could just keep going +3, +3, +3 until I eventually find a 7. You could also just kind of ask yourself, you know, okay, if going up by 1 here made this go up by 3, well, the number I want is a 7, right? That's what I want. Okay, so what would I have to do to this 1 to make it become the number I want? Well, I'd have to add 6, right? So what would I have to add up here plus what so that this would work? And so plus 1 goes up by 3, plus how much goes up by 6. And some of you might already see, oh, I have to go plus 2. But you could also say, well, let's take these two numbers, 1 over 3, and that should be proportional to whatever I've got here, some number over 6. And you can cross multiply, or you can just think about, well, 3 has to double, so the 1 has to double, and this will be a 2. So I'm going to go plus 2. And if I take 1 and I add 2, I'll end up at 3. So my x value equals 3 when the y value equals 7. And that confirms what I got down here. Okay, so those are confirming each other. Now I can also take a graphical approach. And by a graphical approach, this is how we're going to think about it. So I'm just going to rewrite my equation. And I'm going to think of this side and this side that it's equal to kind of as their own separate functions and own separate equations. So I could say this side over here I'm going to call y equals 3x minus 2, and this side over here I'm going to call y equals 7. And I'm going to graph these two functions. Okay, so this first one, the y-intercept is going to be at -2, so I can go down here to -2, and it's got a slope of 3, which means that every time I go over 1 it'll change by the slope, which is going up by 3, over 1, up by 3, and so on. It's going to keep the pattern going, and the other way too. And so I'll end up with this line that's got a slope of 3 and a y-intercept of -2. And then I'm going to graph this line, y equals 7. And you want to be careful. Does that mean I go over to 7 and graph a line this way, or do I go to 7 and graph a line this way? My y-axis here, my x-axis here. Well, when are the y values, like right now the y value is 0, 1, 2, 3, 4. I want to go up to where the y value is 7, which is this spot. And y equals 7 here, it equals 7 here, it equals 7 here. Anywhere along this horizontal line are all the values where y equals 7. So that's the line y equals 7. This is the line y equals 3x minus 2. Well, when are these two functions equal to each other? Well, they're not equal here, and they are equal to each other right there where they cross, which, if I think about it, when they cross here, what x value was that at? Well, that was when x equaled 3, right there. So x equals 3, and the x equals 3 when the y value equals 7. Okay, and so that also confirms what we found in the algebraic and in the numerical approach, that x equals 3. And so you might think, well, yeah, but why don't we just do this? This is the fastest. And it is, and it's useful. And if the point is simply to find the number 3, then yes, I would do and recommend the algebraic approach. But one of the things that you really want to make sure you understand is just a deep understanding of how are these things all connected. How does it all work together? How can I take a mathematical idea like this equation and think about it in more than one way? And so this can be a way for students to see that. And this graphical approach leads into systems, or this can be a nice review of systems. So it gives you some different things to look at. All right, hopefully you found that interesting, and okay, Chris, so cut the video till right now. Now you could also look at what if this equation, what if this had been an inequality? Like what if I said 3x minus 2 is greater than or equal to 7? Well, then that can change my answer, right? So I end up changing here. I don't have to flip the sign at all on any of this stuff, so I'll end up having to change my answer there. But I could also say, okay, well, when is my function greater than or equal to 7? Well, my function is greater than 7. Well, here's my function 3x minus 2. When is it greater than 7? Well, it is up here. Up here it's greater than 7. So it's greater than 7 at all the x values that are going this way. So it's greater at all the values going this way. And so if I was to graph just the x-axis, that would be my solution. So here's 0, here's 3, and so my solution to the inequality would be everything going that way. Okay, so sometimes going from two variables to one variable, that might be helpful to show also. Okay, and I could look at my graph. You know, when is this function going to be greater than 7? Well, it's going to be greater than 7 everywhere over here, since all these numbers are going to be less than 7. All right, and thanks for watching.